And so the most effective enzymes are the ones that have the highest activity. So enzymes are really quite remarkable, and nature has done an amazing job in creating them. So the enzymes can be thought of as molecular scissors. So they literally chop up the cellulose strand. And some enzymes work from either end of the strand, or some enzymes work from the middle. So they work in harmony with each other. They're basically synergistic. And so they work together as a team. Hemicellulases do the same thing with hemicellulose. So they break it down into smaller sugars, which can be fermented. And then there are some other enzymes. They're called accessory enzymes that also work to enhance the accessibility of the cellulose through oxidative cleavage in one example. So the end result of all of this is a stream of sugars ready for microbial fermentation. Now, we could get much more detailed about this. There's lots of different types of cellulases, lots of different types of hemicellulases and so forth, but that's the gist of it. Cellulases and hemicellulases, and the cellulases work together as a team. What makes a good enzyme? So there are a number of things that we look for in an enzyme, and a number of qualities of that enzyme that we can improve through, say, protein engineering. And so the most effective enzymes are the ones that have the highest activity. So they break cellulose down the fastest, and you can use the least amount of enzyme with the most amount of cellulose. So the so-called highest specific activity of the enzyme. The enzyme should also be stable under the conditions where it's used, so we can reuse it over and over again without having to replace it. And ideally, if the enzyme is also active over a wide temperature range, that's also an advantage. And then we also want the enzyme to be tolerant to something called inhibition. And what I mean by that is either if the enzyme is slowed down by the presence of the product it makes, or if the substrate of the enzyme is present in a very high concentration and that slows the enzyme down, best if we can avoid that, so we can minimize product inhibition or even substrate inhibition. And then finally, we want these enzymes to play well together.